We present ChronoLens, a novel visualization technique for exploratory time series analysis. ChronoLenses allow the user to build advanced visual analysis pipelines for various kinds of tasks and datasets. Here, two time series have been loaded in a classic stacked view. To create a lens, the user first specifies the lens parameters on the lens creation toolbar and defines the region of interest using rubber band selection by directly brushing it on the panel. The blue focus bar represents the region of interest in the input time series. Data points in this region are transformed and displayed according to the current lens parameters. Since the lens creation toolbar remembers the configuration of the latest lens generated, similar lenses can be easily added by initiating new rubber band selections. Lenses can be moved freely to any other location and dragged to another panel. The user can rescale the plots by using the mouse wheel, or adjust the region of interest by dragging the red handles. When the mouse cursor enters the lens, a toolbar appears to provide easy access to configuration parameters such as changing operators and plot type. The auto-adjust plot mode can be activated or deactivated via the toolbar. While moving the lens, the plot is automatically shifted and scaled vertically to fit available display space. By scrolling the mouse wheel and dragging the plot while holding the control key, the user can also adjust the plot manually. Properties of the currently selected lens can be modified using the Property panel, including additional parameters such as the number of bins of a histogram. With ChronoLenses, the user can build lens hierarchies to perform advanced data analysis tasks. Let's start with a basic lens that simply magnifies the region of interest. To perform cross-data stream computation, such as cross-correlation, the user can create a child lens by first specifying the operator, clicking the Create Child Lens button, and then selecting the region of interest. The parent lens provides the child lens with its resulting data as an additional input of the binary operator, in this case, cross-correlation. The user can perform further visual exploratory analysis by adding new lenses to the hierarchy or modifying the lens operators at any time. Changing a lens in the analysis pipeline propagates the computation result down the entire branch. When hovering over a lens, all ancestors are highlighted using a green glowing effect. A tooltip is also displayed with basic information such as operators, scale, and focus range. The user can easily pipe lenses by placing one lens fully on top of another, where the result of the lens below becomes the input of the lens above. When a lens is selected, the tree view shows all lenses upstream in the analysis pipeline. Here, the final result is calculated from the result of the lens below, which is computed from data streams of its two ancestors. Lenses are translucent, enabling the user to make basic visual comparisons. Lens translucency can be changed globally in the Property panel. To avoid visual clutter, a lens can be minimized or maximized using buttons in the contextual toolbar, or by double-clicking the focus bar. The user can detach the lens from its focus bar by clicking the lock button. Clicking it again reattaches the lens to the bar so that they move synchronously. Double-clicking it recenters the lens on the focus bar. ChronoLenses can be grouped and synchronized to perform various analysis tasks that involve lags in time. Any lens can be added to the currently selected group via a context menu. When selecting one lens in a group, all other lenses in the same group are highlighted in green strokes. Dragging one lens in the group moves the whole group with fixed relative positions in time. Lenses can also be ungrouped. ChronoLenses also support multivariate time series analysis. Here, for example, the autocorrelation plots for each variable are visualized in the left-hand side lens. Some special operators are available for aggregating multidimensional data, such as point-wise maximum values. The user can also switch to the stacked view mode to display the plots separately. To view plots only on specific dimensions, The user can configure the filtering operator by selecting the corresponding items via the contextual toolbar. Filtering expressions can also be edited through the Property panel. To have a finer view of long time series, the plots can be scaled using the mouse wheel. Lenses can be dragged and dropped onto blank panels. The resulting data computed by the lens is then magnified and shown on the new panel. New lenses can also be instantiated on the panel, dragged and dropped to another blank panel, and so on, enabling multi-scale navigation and analysis. We have presented ChronoLens, a flexible visualization technique for the exploratory visual analysis of time series data, in which the user can build flexible analysis pipelines by interactively manipulating multiple ChronoLenses as the analysis components.